Welcome to another episode of Ape Answers. In this episode, episode 7, we were asked a question about ground plane radials for vertical antennas. Let's take a look at the question. So Corrigan 88101 asked, how can I calculate the length of the ground plane wires? And I gave him a pretty quick and dirty answer. I said radials are pretty forgiving. Typically you would want them 1/4 of a wave of the lowest frequency you are operating on. But there's a little bit more to this answer, so let's take a little bit of a deeper dive. So our first stop is going to be the 2022 ARRL Handbook. In Chapter 21.3, they talk about vertical ground plane antennas. Here you can see that I've highlighted some text, and it says one of the more popular HF antennas is the vertical. It usually refers to a single radiating element erected vertically over a ground plane of radial wires. A typical vertical is electrical 1/4 wave long and is constructed of wire or tubing. The vertical antenna is more accurately named the ground plane. Because of the conductive surface, the ground plane creates a path for return currents to the feed point, effectively creating the missing half of a half-wavelength antenna, like a dipole. Another name for this antenna is the monopole or sometimes the unipole. That's one of the things about amateur radio that I find very frustrating and confusing. We use many words to describe the same thing, and it just creates confusion. Anyhow, let's take a look a little bit further down and see what we see. Here at 2131, it says ground systems, when compared to horizontal antennas like a dipole, verticals suffer more acutely from two main types of losses, I should say. Ground return losses for currents in the near field and far field ground losses. Ground losses in the near field can be minimized by using many ground radials. This is covered in the sidebar, Optimum Ground Systems for Vertical Antennas. So one of the things is that these currents that are coming off the element of your antenna do get absorbed by ground. And that's why we talk about things like perfect ground, good ground, because we want these currents to be reflected and then propagate through the ionosphere so we can make our contacts. Let's take a look at Optimum Ground Systems for Vertical Antennas, which is a little bit further down. And before we do this, I did want to say I really encourage everybody to buy the handbook. You don't have to buy the 2022. You can get a paper copy. It doesn't have to be the PDF like I bought. But I'm not trying to shill for the league, but these are a tremendous amount of great information that will help you in your journey of ham radio. And so basically, this is an excerpt from an article John Stanley, KE4ERO, put together. And I'll let you read this. I'm not going to read through everything. But he did a little bit of a study, and he took a look at this at vertical antennas and came up with this table 21A. And in here, he talks about configuration designations A through F. And then he talks about the number of radials in each one of these configurations, 16, 24, 36, 60, 90, and 120. Now you start to say to yourself, wow, this is like crazy, 120 radials, that's a lot. And it sure is. When I'm operating portable, I typically use 4 radials, about 1/4 of the wavelength of the lowest frequency I'm operating on. And I typically would only use around a 20-meter antenna, which is about 17 feet tall. So I use about 17 feet, sometimes 15 feet, just depending. And I really compromise with 4 radials. So there's a couple things to consider. In each one of these, there's different lengths of the radial wavelengths. So here it's only 10%. So it's not a 1/4 wave, it's 1/10 of a wave. Here we have 12.5, 15%, 20, 25, and 4 for 40% of a radial. And he talks about the spacing, but here's kind of where it is important. The total length of radial installed in wavelengths. So at 16, it's 1.6 waves of wire. As you go further up, 48 waves of wire at 40 or 80 meters, that's significant wire. But we talk about power loss in dB at low angles with a 1/4 wave element. So with 16 radials, you're losing 3 dB of your signal, which is half. The further up you go, the lower this gets, all the way to 0. If I had a permanent home installation of a vertical antenna and I wanted to minimize losses, obviously I would go with more radials. But I think the law of diminishing returns typically recommends folks look around 16 to 36, with 36 probably being the most optimum number with 1.5 dB of loss. Also, here is the ground feed point impedance. And you can see the more radials you create, the lower your impedance here, which can also be a little bit of a dramatic thing for you. There's some other things down here. It says there's some things that jump out. You can only install 16 radials in case A. They don't need to be very long. 0.1 of a wave is sufficient. You'll use 1.6 waves of radial wire in total, which is about 450 feet at 80 meters. So the most important thing is down here at the bottom where it says, so there you have the trade-offs. No matter what you do, you're going to be making a compromise. So you're going to need to determine what is appropriate for you and what kind of space you have, and also what are your budgetary constraints. I'll link this article below, but this is from On All Bands, which is a blog that is produced by DX Engineering that's pretty good. And here it says how long, advice for installing ground or above ground radials. And when you go through here, it covers just about the exact same thing. Right here it says, Stanley compiled the following table, which appears in the ARRL Antenna Book 22nd edition. It's exactly what we were looking at. And maybe this is a little bit easier way to read and consume that information. But here he goes in reverse direction from 120 to 16. And again, I think somewhere around here, 36, 24, 16 is probably where you want to be looking. But you are having half of your loss with 16 radials. So here's another article that I'll have linked below. And this is from Step IR. They're an antenna manufacturer. And in this article, they really make a case for elevated radials versus ground-mounted radials. And when we take a look at this, he goes through some advantages and disadvantages. One of the advantages is radials on the ground are non-resident, so one length, 0.1 of a wavelength minimum at lowest frequency works on all frequencies. The big disadvantage of these is it takes 120 radials to equal an elevated vertical with 2 resonant radials. And then here it says about 90% efficiency. So with ground radials, if you're really driving for efficient installation, you are going to make an investment in copper because you're going to want a lot of copper on the ground, a lot of radials, and we kind of talked about that already. Down here when he talks about elevated mounting, the advantages are the efficiency with 2 quarter wavelength radials. It requires 2 quarter wave radials minimum for each band of operations, and radials interact as spacing affects length. And this means you need to do significant tuning if you're using a multi-banded antenna. Higher profile means that it sticks out a little bit, but maybe you have a lot of property, maybe you have time to tune this antenna, and it's not really a problem. So a couple of things to take away here is that what you do for a portable antenna is going to be different than what you do for a permanent installation at your shack. And you're going to have to make a determination as to what is appropriate for you. Anyhow, I hope you like this video. Remember, if you ask a question, you might appear on the next episode of Ape Answers. Thanks for watching, everybody.